Hello, my friends of Water Labs. Welcome to the second class of this course of GIS in Water Resource Management. What we are going to do this time is to work with the georeferenciation of maps. When do you need georeferenciation? Okay, if you are doing some hydrological modeling over a certain area, maybe you might find some old geological information, old or some information that is is paper based, or maybe this information lacks some georeferenciation. We are working about all data. Okay, so in order to do that, we are going to work with the georeferenciation. Okay, let's say, so everybody please open QGIS. Here, let's open QGIS, and then we are going to the georeferenciation was is a really old feature of QGIS, so it was from maybe the version 0.8 even before, and the process has not changed much over time, so it still remains the same. Okay. Okay, I hope that you are fine. I see that 5 people are connected right now. As I told you, maybe you were not connected to the class before. If you have any questions, let me know it through the chat. If you have any problem, you can send me screenshots through WhatsApp, and we hope we can fill this. We can have a great class today. So let's do a new project, and georeference is here. Okay, georeferences is here, and the raster. However, sometimes could be that georeference is not there. Okay, that happens sometimes. And why do you have that? It's because sometimes you don't have no, time before it was a plugin, but right now it's not a plugin. Yeah. Point sampling, DB manager. No, it has to be there always. Okay, it has to be there always. So raster, let's go everybody to georeferencer. Okay, everybody, let's go to georeferencer. If you are here, please type yes one. Okay, so here you can add a new open raster. That is the one that is not georeference. You can do georeferenciation. You can generate a script. That's in case that you want to do, because with the GIS script you can do the same process for many maps. Then you can create your points, remove your points, and then this you can define some transformation settings and so on. So for our case, we are going to open, what we are going to open is on the course material, on section 2, on practice, on data, we have a raster that is called a TIFF raster, but also you can reference PNG and GPG and any other image. Okay, so let's say mapa de Peru.tif. Okay, and that appears here. Okay, you can reference that and it will appear here. Okay, what is the purpose here? We need to add at least 3 control points, okay, because these 3 control points will reference the coordinate of the image to the geospatial coordinates. Okay, so that's why how we do that, by inserting these control points. Okay, so but first of all you need to know which are the coordinates, I mean the real coordinates of these control points. In this case it's easy because we have some guidelines. So for example, this is latitude 0, latitude -6, latitude -9, longitude -78, -72. Okay, so this is easier. Okay, we are going to work with another one that is a little bit more like more real, because we are going to georeference um, um, panchromatic Landsat image, okay, that has no reference, that has no georeferenciation. Okay, so here let's do a zoom here, okay, because we are going to use this. Well, we are going to use 4 points here, but actually in order to do it you can do it with 3, but in our case we are going to do with 4. So we are going to add a point as close to this corner as close to this intersection, and then say which will be the east of that will be -78, and which will be the north of that will be 0, okay, and here as well will be, the east of that is -72, and the north of that will be 0. Okay, so here we have -78 0, -72 0. Okay, so, and then we go back, and then we are going to work with these ones. So here, okay, these ones will be, okay, so here we see some of the air curvature, so that is why the lines are not perpendicular to the x and y. Okay, here the east will be -78, and here the north will be -18. Okay, and here as well the east will be -72, and the north will be -18. Okay. Okay, so these are the ones. If you are here with me, please type yes too. If you are here with me, please type yes too. Manala asks, why the sign before the number as the number appears without it? Okay, yes, on the manual the number appears without sign, but is minus because we are talking about the southern hemisphere, and is on the latitude, and is minus on the longitude because we are talking about the western hemisphere. Okay, if you are here with me, please type yes too. Okay, Manala says, it is actually not clear for me which coordination system I am talking. Which coordinate system I am using? WGS84, latitude and longitude. Okay, so if you are, for example, in the northern hemisphere, you are talking about your coordinates will increase on the y direction. So for example, so here you will have 2, 4, 6, 9. Okay, but in the southern hemisphere, the y direction is the y direction is southwards. So actually here you will find 0, 2, 4, 6. Okay, so that is why, but everything is minus for us. Okay, If you are here, please do, yes too. Okay, so here we are going to work with, okay, so here we need some parameters for the translation. Okay, so in the parameter for the translation we can do a linear translation. Linear translation is just that you move the map and then you rotate the map and then you expand the map. So this is the linear translation, and I think that if your map is kind of very regular, this is the better approach. So there are other approaches like polynomial and so on that we are not going to deal with that, but in case that you have some huge cartographic, you will have many features, or like, I don't know what you can have, you can search in between those. Okay, so we are going to reference in WGS 84 because we are talking about latitude, the geographical coordinates, and then we are going to store this on the course material, in the course material, no, not on the course material, in the course exercise folder. We are going to create a new session 2 folder because we are not in session 2, and here inside session 2 we are going to create a new raster folder, and here on this raster folder will be the original name of the file plus the suffix underscore modified. Okay, this underscore modified is actually by default from the georeferencing, and actually we don't usually change that. Okay, so we keep it that way. So okay, here we can save the GCP. This is because maybe you wonder, because you want to place the to refine this, you can do it through the GCP folder, and that's it. And then let's say load it in QGIS when it's done. Okay, so or download it just to follow the manual, because we can open that later on. Okay, so with that, what you have done is that you have defined your geotransformation. Okay, you have defined your geotransformation. However, you haven't done the geotransformation. In order to do the geotransformation, you need to run your geotransformation. Okay, you need to run your geotransformation with this, and nothing happens here. However, if we go to the documents, to the exercise folder, to the session, to the raster, we can open map of Peru, and this map of Peru is, look, this is the canvas projection system, and actually if you place your mouse here, it has to be minus 78, minus 18, minus 78, minus 18, minus 72, minus 18, minus 72, 0, minus 78, 0. Okay, and if you have seen, there are some issues here, so actually it is not that right, but you can play around with the folder in order to make it right, or maybe you can work with the handler. Maybe since this, yeah, maybe you can no, yeah, it's right. I don't know why this point actually is kind of chisel, but if I go here, this is mine. Oh no, okay, yeah. There are some issues there, but you can play around with the control points in order to solve this. Okay, or like it will be easier is just to play with 3 points, because it might be that in 4 points you are adding some results, some problems. Okay, if you are here, the last thing that we are going to do is we are going to save our project, and where we are going to save it, in the exercise folder, session 2 we are going to create a QGIS folder, and as actually QGIS folder, and this will be georeferencing 1. Georeferencing 1. Okay. No, it's, well, georeferencing, sorry. Actually, it's with just one R. Georeferencing 1. Okay. And I will delete the other one. So this. Okay. Great. So if you're here, please type okay, there are two questions here. First, okay, let's go back to the georeferencing. You can go back to the referencing here, okay? Okay, I cannot go back. Okay, let's. Okay, raster georeferencer. Where it was? Okay, here. Okay, by default, you are working in WGS 84. Okay? By default, you can work in WGS 84. Okay? This is by default. Okay? So, if you want to work, because the other ones will be in UTM, we are going to do the same procedure, but with UTM. Okay? And also, this is what it is asked. The other is, can you move these control points just in case? Yes, you can move it. However, I cannot recommend it. Okay? So, for example, sometime like I can move it, but this will do a lot of harm. I mean, this will do a lot of pain in your transformation, because actually you can do a lot. What is my suggestion is to do it again. You do it file, reset your references, and do it again, because I mean, and this is one of the purposes. If you haven't done so, it is strongly recommended that you repeat this procedure once again, because not because like we don't care, it's because practice is the only way that you can manage this tool. Okay, I have been working with this tool maybe for the last 10 years, and even that I know that in order to do it right, I have to repeat that many times. Okay? Yes. So if I close this, I save. So if I go to georeference, okay, if I close, I will lose my georeference project, but it doesn't matter because I have already georeference. Yeah. And the origin, this is in WGS 84. That's why I don't need to do any change of projections. Okay, on the next exercise we are going to work with UTM WGS 84, but 18 South in Transfer Mercator. Okay, if you're here, please type GIS3, save your projects. Yeah, if you are here, please type save GIS3 and save your project. Okay, great. So let's create a new project, and let's go to raster and georeference. Let's create a new project, and let's go to raster and georeference. Okay. Yeah. What we have done is a new project and then raster and georeference. What we are going to open is on the course material Section 2 practice raster. We have another one that is called, what is called? It's not on data, it's as a GPG, and this is to show you that you can reference as well some basic graphic files, I mean PNG and GPG. And let's call it, let's use this one, mapa provincia de Lima dot PNG. Okay, so we are going to work a standard PNG file that could be, okay, so this is a file that you might find it in a report, so you have only the figure of the map, but actually you don't have the map, so we are going to georeference this. Okay, so there is some tricks here, so those are the 1, 2, 3, and 4 control points, okay, so that we are going to use. This is mostly just to help you with the realization of this tutorial. Okay, so let's do it. So I will do a zoom over 1. I will add a point here, and to this point actually we don't know right now. We are sure we are not working on geographical, but this is not the place where we have to worry about that. So what we have to worry is just to locate us in the as close as to the center or to the intersection of the two lines, and to type the right coordinates. So the right coordinate here will be 150,000, and the coordinate here will be 8,800,000. Okay, so this is 8,800,000 and this is 150,000. Okay, let's say okay, and this is the same as it appears on the material, on the course material. Okay, so let's go to 2. I can do zoom out and zoom in with the scroll wheel. And then here I can do it with 500,000, and this is as well 8,800,000. If you are here, please type yes 2. No, if you are here, this is in UTM. Okay, so yes, this is in UTM, but till now we have not declared that this is in UTM, so we are just inserting coordinates. Okay, if you're here, please type yes 4. Yeah, I will tell the program later the projection. Yes, right. Okay. Yes, 4. Great. You're doing amazing right now. Okay, so we have 1, 2. I don't know why, but those appears right now. I mean, at the beginning was not like that. I don't care about these lines. I mean, or maybe I haven't researched much about what are these lines. What I know is that I follow the steps, this works. Okay, so here, let's say here on number 3, let's add a point here, and then following the course material, this is 400,000. Okay, and then this is 8 million. 8,550,000. Okay, the coordinates are on the course material. You can, in case that you don't see it from the screen. This is 400,000, 8,550,000. Okay, and then we go with the pan tool here to number 4, and this is another one that is 150,000, and this is 8,600,000. 150,000, 8,600,000. Okay. Okay, so we can do to the extension. So we have 1, 2, 3, and 4 following this, and then the coordinates that you have inserted are here. However, this, well, this put the scientific notation. Okay, great. So we have the 4 points. So where we give the coordinate system, this is a great question. Where we give it? Here under transformation settings. Here under transformation settings, we are going to give the transformation settings of the coordinates that we have given, and which will be these ones. So in our case, it will be 32, that means WGS 84, a transverse Mercator. If you are in the northern hemisphere, is number 7. If you are in the southern hemisphere, is number, no, if you are in the northern hemisphere, is number 6. So it's number 6, that's why you have this in northern. Okay, but here we are in the southern hemisphere, is number 7. Okay, and we need the zone. Okay, in this case we know that this is the 18 south. Okay, we know that. Okay, so you have to search for the zone where you are working with, okay. This is kind of an issue because there are countries, every country has its own projections and every country has its own zones. Okay, so you have this 32718, and then you have to select this. Why you have to select it? Because otherwise you haven't selected. If it doesn't appear here, actually you haven't done anything. Okay, so you have to select. Okay, this is a certain trick, so it doesn't I mean, it is not enough just to type the code, but you have to select this. Okay, and then here you specify that this is 18 south. Okay, and then we are going, where we are going to store this, under the exercise folder, session 2, raster, and then here we leave this Mapa Provincia Lima, and the georeference actually adds the modified to the name. Okay, great. So we can do okay. Everybody can do okay. So please run your transformation. I will leave this. Okay, once you type okay, just run your transformation and upload the georeference file, the georeference raster, and type yes 5. If you have any questions, let me know. Okay, what is the next step is that you press OK, you run your transformation, and on QGIS you open the reference raster. Okay, if you have done it, please type yes 5. If you have any questions, let me know. if you are here, Tom asks, I miss how you did to save the point. I didn't save any point. Ah, okay. Sorry, Tom. I haven't saved any. Okay, so I just have defined it. Okay, and then I went here, and if I want to save the point, I have to do it. I have to press this. Yeah, and actually it will save the point here. Okay, yes, but I haven't done so. Okay, what does it mean? That if I open the, okay, all of these points will be lost after my geotransformation. Is that right for you, Tom? Okay, if you have done this, please type yes 5. If you have any problem, you can always send me your screenshots to my, or like you can ask for more time. Okay, great. So say okay, and then we run the transformation. Okay, what we did is a linear transformation, so we can close this. If we close, we are going to lose everything that we have done, but because we are confident that we have done this right. So this is our geotransformation. Okay, if we want to know that this is geotransformed, please look at this. Okay, please look at this. The system of projection of the raster is WGSAT is 32718. The system of reference of the canvas is the same. Okay, but what will happen if I do a quick map service of Google satellite? What will happen here? You will see that the canvas projection actually change. Okay, the canvas projection actually changed to a certain Google projection. Okay, sorry. Okay, disgusting. No, it has not changed. Sorry. In previous version it changes. Okay, right now it doesn't change. However, this is great. Well, we have here the Google China, but let's work with the normal Google. Okay, and here we see that our map is so well geotransformed. I mean, this is the most cheap trick to see that your data is right. Okay, so if your data is kind of doesn't fit very well, what it will means is that you have to repeat the procedure, but taking more into consideration the exact position of the points. Okay, these exercises are not strictly related to following the process with precision, but that you know the process. Okay, if you are here, please type yes 6. Let's save our project save as georeferencing 2, because what the next thing that we are going to do is that we are going to georeference a panchromatic Landsat image that has no geotransformation. Okay, so I will save it and then I will open a new one. Okay, the next one that we are going to georeference is a Landsat image. Okay, this one is a Landsat image, so we are going to open the raster, and then here on GPG we are going to work with, this is GPG and this is TIFF. In our case we are going to work with this one that is a panchromatic image. Okay, that comes with air from NASA Air Data Search. Okay, and this is our image. Great, so if you have seen, this is an image. Okay, so this is I mean the extension of this is huge. Yeah, and then we are going to reference that. Okay, based, but not based in the intersection of some line, but on some features. Okay, so we have to I mean, we are going to work with this feature, we are going to work with this feature, and then we are going to work with this feature. Okay, so be aware of that. Okay, so let's do okay. Manalas, if we add more points, will be better. Not that much, because okay, in my perspective, if you are mod points, actually the linear one won't work better, so you have to do another transformation of Hermer. But what is doing a transformation of an image? It's actually deforming. I mean, it's actually transforming an image. So, and something that is the most valuable about spatial data is that the data is related to the position. So actually you are shifting positions. Okay, so in my perspective, it will be better to play around with the control points, with the decimals of the control points, in order to fit it better, than to insert like many control points. Okay, but this is my perspective. Okay, if you are here, please type G7. If you are here, please type G7, because we are going to do here on this lake, there is a lake here, we are going to look for this point here. Just here in this point we are going to add, just here, look, just here we are going to add a coordinate -79 133 630 -7.25 8521 -79.133630 -7.258.521. Okay, if you are here, please type B7. Okay, you are doing great. Okay, so this is geographical coordinates. Yeah, those are WGS 84 coordinates of a Landsat image. Okay, and here is where the decimals actually play a huge role, because in geographical coordinates the decimals are, I mean, one digit that is on this position could mean many meters. Okay, so so here this is the first point, and this is as well on page 9 of your material. Okay, and then we do like this. If you are here, please type yes. If you are here, please type yes 8. Okay. Okay. Yes. No. No. I had some. Well, I am back. Okay. So here, yeah, we have inserted this point, and then here, okay, here I have to insert this. Okay, where is this point? Is you here you are going to see a gully, and then here you're going to see a river. Okay, here we are going to do another point. Okay, and this is a river, and this is a small river, a tributary. Okay, so the point that we are looking for is the junction. Okay, here this is the junction, so here we are going to give here the point at the junction, and this will be minus 77.829949, and this minus 7.348486. okay, minus 77.829949 minus 734.8486. okay, great. Yes, so this is the other point. This is the other point. Okay, so if you are finished the other point, please type yes 9. If you have finished the other point, please type yes 9. Okay, we go back. Okay, so we have 2 points. Okay, the third point is the most tricky part. Okay, if you are here, please type yes 9, because where is the third point? Okay, so here we have one. I will do a small zoom here. Okay, so because this is the first point, this is the second point, and the third point is in this lake. Okay, this lake, this one, this lake that looks like Cyprus. Okay, here let's look at this point. Okay, so this point, and then here at this point, this is a lake, and on this lake there is a point here. Okay, so you see that here you find a kind of an arc. Okay, and here you're going to insert the third point. Okay, here you're going to insert the third point, that is 78.337841 minus and minus 7.33598. 78.337841 minus 7.32398. okay, great. And I don't know why it has this. Okay, I don't know why. I mean, I have to review more about the information. Okay, so these are the 3 points. If you are okay, great. So I will show the gully. Where is the gully? The gully is here, in this part. Okay, here in this part you're going to see the gully and the conjunction with the river. Where is the gully? The gully is here. Okay, if you are here with me with the 3 points, please type yes 1. If you are here with me with the 3 points, please type yes 1. Okay, there is great question of Manal that say only raster can be your reference. Here, yes, because if you want to georeference vector data, actually what you have to do is you have to define a system of reference. Okay, this is different. I have done that in one tutorial, okay, because I somehow from a PDF I got some vector data on certain coordinate system, and then I have created some coordinate system to georeference that. Okay, but this is that way with vector data. Okay, who else is here? Please type yes one. So this is the third point, this is the second, this is the third point, the other was the second point. Okay, anybody else? Anybody once more time? If you have any problem, please let me know. About georeferencing, I will the main, I mean the most, well, there are tutorials, but I will strongly recommend this, the actual, no, for documentation for, so no, this is 3.18. Okay, yeah, I will recommend you this, yeah, because this is from the testing, oh sorry, latest version. Okay, yeah, I would strongly recommend to see this. Okay, great. Okay, so let's go here to the documentation. We are going to work with the linear. The resampling will be in the nearest neighbor. We are going to work with WGS 84, but in order to find this, it will be 4326. Okay, great. So this is the one. And then we select this because it has to be here, WGS 84. Okay, great. And then we are going to work where we are going to store it is not on the in our folder class, in session 2 in raster, and then we will leave this is the original name and with the modified. Okay, great. We are going, well, we don't want to save the GCP points. In case that you want it, you can do it. Okay, and that's it. Just type OK, and then run your geotransformation and then upload it to your, I mean, close this and upload it. If it works better, if it works right with the quick map service, type yes 2. If it works great with the quick map service, please type yes 2. Okay, great. So here I type OK, and then I run my geotransformation. It's a kind of, it's a big transformation. I can close it and says that your reference was successful, and then here I will open my modified version. If I want to know how well I modify it is, I just have to use a Google satellite. Okay, I have to assure that it's below my layer, and then here you will see. Okay, here you will see, and then you will see, okay, I did it great, I did it bad, I have to use another control points, and so on. Okay, great. We are going to save our project, and this will be georeferencing 3. Okay, there is on the manual course manual, there is one more exercise that is for georeferencing ancient maps. Okay, this can be helpful for you, because if you want to measure, or like if you want to see the impact to the how say, the impact to the riparian area. I mean, if you want to see how was the change in the flooding bed of a river, yes, it would be better to use an ancient map. I mean, a map from the year 180 for the 1800s, and then you will see how the river has changed, or how other features has changed. The exercise of that is on the course material, and then I leave you as a complementary material here. Okay, so what we are going to do, if you have any questions, let me know. And then what we are going to do next is the second part of this class, that is the raster. We are going to work with rasters, and these ones is more related to the work of is on the way to work with the basing determination and so on. So I will open this. Okay, great. So let's do two things. Okay, the wait. Okay, let's go to there is a website that we need for this, that is the Air Data Search. Okay, here on the Air Data Search, I am not logging. I will log out. Okay, here I will log out. Okay, and then you have to go to the Air Data Logging. Okay, I will drop this. Yeah, so this is the Air Data. Okay, where am I am here. I will copy paste through the chat. Okay, great. And then I need to log in, but for that you need an account. Okay, if you don't have an account, please do so. And then if you have an account, I mean, if you don't have an account, type no. Okay, because I want to know. You can register, and it's the same as doing any other stuff. Okay, and then you have to sign in. So I will sign for my account. And then I have signed with my user and my password. And here I have already signed. Okay, in case that you don't have it, yeah, I will leave you. We are going to make a pause of 10 minutes. Okay, why we are going to make this pause of 10 minutes? Because in order for you to create an account and so on, and maybe you want to go to the restrooms, because we have already 1 hour of class. Okay, so 10 minutes pause. 10-minute pause. Come back. at 7:14 Amsterdam time. If you have any problems, if you have any problem, I will be responding the chat, okay? However, 10 minutes of pause. Hello, hello, hi, are you there? I hope that you are there. Okay, so we are back, and then we are going to continue this, and I hope that you have your AirData search account. Okay, great. So what we are going to do now is we are going to define an area. Okay, so how we are going to define an area? We can define it by a polygon, rectangle, point, circle, or a file. Okay, in this case we are going to define it by a rectangle. Okay, rectangle. Okay, and then we are going to use these coordinates minus 8.086 comma minus 17. This is the southwest corner, 79.088, and this is minus 7.363 comma minus 78.010. Okay, and this is actually, if I go here, actually will point the area that is the area of the basin that we want to explore. Okay, so if you want that I do it again, please type do it again. Otherwise, if you are here with me, please type yes 3. Otherwise, if you are here with me, please type yes 3. Okay. Two questions. Okay. I will do it again. Okay, great. So I will do it again here. Okay. Okay. The first question is, what if you don't know the coordinate? If you don't know the coordinate, you can use a shapefile. Okay, or you can do like this. You can go to the place, you can do a zoom in, and then you can do like this, and then because you know that this is the area. Okay. However, in our case, for our case, but if you have a shapefile, you can insert that shapefile as well, and this is what we are going to do in other tutorial. Okay, in other part of this course. Okay, so for now we are going to go here and then click on rectangle, and here on rectangle we are going to insert the minus 8.086 comma minus 79.088, and here with minus 7.363 comma minus 78.010. Okay, great. So if I go back here, it will appear this area. Okay, I hope that everybody is here. And then we are going to select the type. Okay, and then what we are going to download now, because we are going to use this website many times over this course, is that we are going to download the digital elevation model. So it's a aster. Okay, so we use it's an instrument, yes. And then over the aster we have global digital elevation model, that is the version 3. Yeah, or there are more. There are some uh, radiance at sensor, global forest change, where however where what we want is digital elevation model type 003. Okay, so this is the link that we have, and inside this, how many we have? 4 granules. What it means granules, and this is a ugly name to define image. So each image is a granule. Okay, horrible. Okay, so if we are going to download all of them because we need all of them, so let's go to download all, and let's go here to direct download done, and let's go here to download data. Okay, I will do it again because this seems very tricky, and it's in fact tricky. Okay, there are many ways to download it, and the process is kind not well organized. Okay, so okay, here it's kind of lengthy. I will reload my area, my web. Okay, so here I have the 4 loads. If I press this one, I can download this one, this one, this one, and this one, and it's the same. I mean, or I can download all of them. Okay, I will download all of them. Okay, and then there is only one way to download it, that is direct download, and then here I go to download data. I have to go to download data. Okay, and then you will find for every image you have the name and the name, the name and the name. You are interested only on the name because I don't know what is the name. Sometime I review that, but actually it's not what we are looking for. So we are looking for the dem file. So what will happen if I press here? Yeah, it will redirect. Yeah, and there is a trick here. What is the trick? Is that you are, okay, in my case is downloading. Why? Because I am signed in. Okay, I am signing. Okay, and here is downloading, but there is, okay, here it's downloading as well. So it will be on your downloads, it will be all of these dem files. So there are 4 of them, so you have to download this, and this, in order to prevent some errors, or maybe you didn't find it, maybe it was not the same for you, and so we have those already on the course material. Okay, so in session 2, practice data raster, air data. Here we have all the 4, we have here the 4 files. Okay, so what we are going to do, and according to the material, yeah, we are going to extract, and then for that I use WinRAR. Okay, here I have the name and the num of the num, but I only am going to work with the dem. So here I have it already, so I have extracted with the WinRAR. Okay, very practical. Okay, so and then here I have these, and these that are the same, that are the ones that are going to be downloaded from the website. Okay, so let's go to our QGIS new project. If you were able to be at this step, please type yes 4. If you were able to be at this step, please type yes 4. Okay, great, you are doing amazing. Okay, so let's go to the course material. Let's go to session 2, let's go to practice, let's go to data, and then we have the on air data. We are going to have, as well as the zip version, as well as the num, we are going to have the dem. Okay, so I'm going to open this, I'm going to open this, I'm going to open this, and then I'm going to open this. And what I have open, 4 dem files, so 4 digital elevation files. Manal asks if it's possible to download all the videos. No, but it's possible to see all the videos forever. Okay, so because the link is the same, I mean, if you want to review this later on, you can do it. Okay, great. So here we have four uh, how say, grids. Okay, for tiles. Okay, okay, so here we have those 4. Okay, so let's continue with our exercise. Okay, so what we are going to do is that we are going to merge those 4. Okay, so in order to merge, there are 2 ways to do it. We can do it with the raster miscellaneous merge or as a virtual raster. Okay, raster miscellaneous merge seems to be much quicker. So let's say here merge. Okay, and they say GDAL raster miscellaneous merge. Okay, because we are going to merge rasters. Okay, so here we type merge and this GDAL raster miscellaneous merge. Okay, great. So which are the rasters that you are going to merge? You are going to merge, and if you see, it appears the 4. You want to merge the 4 of them. You want to merge the 4 of them. The float 82 will be the data type. There's no problem with that. And then we are going to store the save temporary file. We are going to store this save to file. Okay, when you work usually with QGIS, you can use the temporary file because this is more practical. But since you are learning, it is better to show you the procedure to store this. So on the in the course exercise folder, session 2, raster, this will be called IST GTM. This is how the 2, this is, and I think that is 3. Well, let's keep it with 2 comp, but because it's the combination of those 3. Okay, and then you just type run. Okay, and then you will find these are the parameters, and then you will find a raster file that is the merge of the 4 parts. Okay, and then you will find a raster file that is the merge of the 4 file. If you are here, please type yes 5. The next thing that we are going to do is that we are going to define a polygon, but we are going to define the polygon with some defined. We are going to, yeah, this is a great question. What is the num? Don't know. I mean, I read something and then maybe 4 years ago I realized that the dem was the ones that I was going to use, but actually, okay, I can open a num file. Seems to be, so it's kind of related to the quality control, but it's actually not a dem, so it's not a dem. Okay, remove layer. Great. All the other instructions stays the same. Okay, what we are going to do is that we are going to define a polygon, but the polygon with our extension. So there are many ways to define polygons as well, but in our case we are going to define a polygon with certain lines, or how to say, we are going to define a polygon on a certain way that because we are going to define each vertex of the polygon. Okay, great. If you are here, please type yes 5. Okay, I'm going to close this, and then what I will do is zoom to layer. No, okay, well, zoom. I will create a new one, create a new shapefile layer, create layer, new shapefile layer, layer, create layer, new shapefile layer. But first, let's look which is the system of projection. We are working in geographicals because the them that you have downloaded are on geographical system of reference. So layer, create layer, new shapefile layer, layer, create layer, new shapefile layer. And where we are going to store this, we are going to store in the exercise folder, session 2, and then here a new folder that is going to be shapefile, and then here that will be called mask, because it will be, this will be used in order to clip the shapefile. Okay, let's do it. It will be on UTF-8 and it will be a polygon. Okay, and for this shapefile, and it will be on WS84. And for this shapefile, we don't worry about attribute table because we are more interested on the extension rather than on the attributes. Okay, if you are here, please type yes6. Okay, Manal as border. Yes, 5. Sorry. Okay. Okay. So let's mask border. Yeah, not mask. Yeah, they call it like this, so that's what. Okay, so this will be our mask. So okay, in order to make it clean, we don't need this anymore. We don't need those names anymore because this is already what we are interested is in this one. So all of these them files, we do right click, we select all of them with control. We can select all of them and then right click, and then you can remove those layers. Then you can remove those layers. Okay, okay. And then what we, okay, so we have the mask and the combination. Okay, here in the mask I will start doing, okay, please look at what I do, then we are going to do all together. Okay, first do what I do. Okay, so here I will select 1 2 3 4, right click, 1. Okay, with that I have created one polygon, and then I will do right click on the vertex and it will appear this vertex editor. Okay, again I will, okay, this is what we are going to do. Okay, but I will do it again. Okay, I get out of this and then I will select I will select this and then I will delete it. Okay, now let's do it all together. Okay, so first this card. Okay, first toggle editing. Okay, so let's start with the pencil. Okay, so here everybody is with the toggle editing, and then we are going to create a polygon. Everybody is going to create a polygon, and the polygon will be somehow here, 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 and here. Right click, one, enter. Okay, control Z. Okay, with this option, right clear, right clear, right clear, right clear, one. Okay, and then we go with the vertex tool, this one, and then we select any of the vertex and we do right clear and it will appear this. If you were able, just type yes6. If you were able, just type yes6. Okay, great. So what we are going to replace. Okay, so we are going to replace. For example, we can select the first one. I don't know why it cannot be selected, but the second one, for example, this will be the x mean, y mean, and the x. In any case, it really depends. I have done it in this way. Okay, but in case that you have done it in the other way, like you will, you just look for this corner unless you have started from this side. Okay, this one, this will be which will be my x mean will be minus 79.088. I minus my y mean will be minus 8.086. Okay, great. So this is the point. Okay, here this will be my x max. My x max will be minus 78.010. My y, this will be my y mean, so it will be the same. Okay, great. And then we need, for example, this one will be my y max, which will be my y max. It will be minus 7.363, and my x max will be the same as this one. No, this one. Control C, Control V. Okay, this one. Okay. For example, I lost my zoom here. There are many options. For example, this is zoom previous. This one is zoom previous. Okay, great. And this will be the first one. Okay, so this first one will be X min Y max. Okay, if you have done in this way, and if you have in this order, so this is the first, the second, the third, and the fourth, please type yes. Manalas, is it possible to show the given coordinates as a chef file? Yes, it's possible to import this. It's possible to import this as points and then create the polygon from the points. Okay, but in our case we are doing this manually. Okay, this is another process with the vertex tool. If you are here, please type yes 7. What is the air? Great question. Don't know. It appeared there. No, not really. Don't know what is there. It appears there on the latest versions of this tool. Okay, if you are here, yeah, yes sir. Okay, so we can get out of the editing. So, and this will be this is already a shapefile, okay, with the defined borders, okay, and then what we need is we don't need all of the shapefile. What we need is just this, because this is too much. It's too heavy. Okay, so what are we going to do? We are going to do a clip. We are going to clip the raster, and here we are going to clip the raster by mask layer. That's why we needed a mask layer. Clip the raster by mask layer, and since we have only 2 layers, this is really easy. It's really easy. So we type click here and then clip raster by mask layer. That will be my comb, and this will be my mask. Okay, match the extent, yeah, and the result will be stored to file, and it will be on the session 2, and this will be astemcom cat. Why? Because this is cat, this is the cat. Okay, astemcom cat. Here, this is how we are going to do, and then here we type run, and okay, okay, and here you have, if you okay, this is the comcat. Okay, this is the total, this is comcat. Okay, if you are here, please type yes 8. If you are here, please type yes 8. Okay, great. So I will close this, and then here we have the comcat. And then if I want to clean this, I don't need this anymore. I mean, I don't want the total is not necessary. I just have to keep the comcat and not even the mask. Okay, but let's keep the mask. Okay, but in general, if we are the content, yep, yep. If you can analyze, if you have the coordinate in Excel, you can create points. Yes, but this is with this option, delimited text, where you have to import the Excel file, but as a comma separated value as CSV. Okay, and I think that in the latest one you can even ask no, just as CSV. Okay, as a CSV you can open this. Great, yeah, because yep. Okay, great. Then let's continue. Then we have the asset concat. Okay, then we are going to reproject it because this is in geographical coordinates and we want it in WS84. So for that we do wrap reproject var, no wrap, var, yeah, var reproject. Okay, um, okay, this is in order to, because when you deal with hydrological modeling, hydrogeological model, you work with UTM, you don't work with geographical. Okay, so here we are going to work with Comcat, and that's why we only keep one raster. And the target CRS, we can insert it here. We pick out this one, I don't know why it was. Okay, and then we type which 32, and this is 17 south, so it's 32717. Okay, 32 is WGS 8480 UTM, 7 means southern hemisphere, and 17 means this area. Okay, so this is the area. Okay, and this map is kind of very useful, and then we type okay. Okay, and then you are going to store this. You are going to store this as you are going to store this as you have to save to file, and then you are going to find this Comcat, and then you are going to add UTM. Why? Because this is in UTM, this is not anymore on geographical coordinates. We can press run here. Okay, this is what it is expected. Okay, and then I will show you a trick here. What is the trick? That the trick or the problem is that when you do a reprojection, actually you have some black borders, and this is related to the reprojection, and these black borders can make some issues somewhere, but we don't right now. We don't have to deal with those issues. Okay, but just to keep it that when you do a reprojection, that is actually a rearrangement of your raster, and it has more stuff. Okay, so this is the reprojected of the geographical coordinates. Okay, and then we can do some Comcat properties, symbology, pseudocolor, classify. For example, in this case, we are going to use the cumulative count because these black borders means those black borders means no data. So actually, you don't want this on your. You don't want those on your color. So yes, let's say that you want quantile not equal interval node. Let's say that you have from 10. Classify quantile. Okay, apply. Okay, well, something like that. Okay, so that was the end of this class. Save your project, and this is rasters. Okay, rasters. Thank you for following this class. I hope that it was helpful for you, and it was very interesting for you as well. I'm going to give just today I posted on the website that I'm going to give as I'm going to give a webinar on a very interesting topic, because right now with this COVID crisis, like there is a lot of webinar, and so you have to be very creative in order to get a webinar where people actually will go. So they say how to do a geological map with QGIS. So in this webinar we are going to do a geological map like this one, okay, where we have the many features, okay, and it will be on 2 times time. It will be have 2 venues, okay, and in this two different time zones. Okay, and if you are interested, you can take this, is free of charge. Okay. Okay. Why I do clip this? Why? Because the problem here is that these points are, the value here is 0. So if I close this, here in this band the value is 0, and I don't want that 0 will be part of my color bar, because actually I'm not interested in this 0. So that's why I tried, and then I didn't get it. So okay, and I say okay, I don't want that 0 will be part of my color scale. That's why I classify this. But however, it takes the 10. Okay, so I have to, I have to define the value that is the minimum value besides the 0. And maybe in this histogram, let's see, the minimum value that is besides 0 is, and I guess is 35, I guess. Okay, so here I can go from 35, classify, and this will be the values that belong to this area, but are not related to this gap in the transformation. Okay, if you are everything here, just type yes 9, and if you have any questions, just let me know.